All right, so going to go over case hardening in the, we'll go ahead and put it onto the next and see what picture pops up. So in this case, I'm using what's called cherry red here in the States as a case hardening compound. There are other ones. I have used a mix of sugar and borax. I've also, there's also casonite. I've used a flour mix with charcoal, ground charcoal, and stuff like that in the past too. The the sugar borax mix, just something to produce carbon as a gas, or CO, and and something to produce carbon in a gaseous form, and a carrier. In the case of a borax as a flux, it helps to cover and coat the material so no more oxygen is getting in. That way, when your steel or iron comes to temperature, the at about the point where the carbon would migrate and go into solution, the the gas can then penetrate in from the outside and be in that oxygen free environment. So here we have a picture. I chose to do a couple of small jewelry hammers out of a mild steel, and then I had a control sample at the end, and I did the same thing. And then I took a hardened 4140 hammer, and that I needed to clean up a little bit anyway, and hammered onto the end of it, breaking the shattering a little bit of the tip of the edge of the peen on that one, the control sample, and putting digs into the hammer. But here's the cherry red. We'll go ahead and go to the next. All right, I'm putting it on. What I do is I bring the material up to temperature. So back when this stuff was first came out, cherry red was a orange. Cherries weren't red, they were more of an orange. And that's all going to tell on everybody's different perspective of how they see color. But I bring the material up to color or up to temperature. I put the material on. I use a flux spoon that I made by forge welding, and put it on it. Let it crust up and dry over. And in this case, I'll put it on both the top and the bottom, and a little bit on the sides, on the ends. And next picture. Yeah, so it'll smoke up. Keep going, next. Yeah. So that's a picture of it right before I hardened it, and that was just the blank that was going to go. Next picture. So there you can see the crustiness starting to develop. In this case, I had put it on the top. I do not see if I had put it on the bottom yet. So next picture. There's it at about the temperature right before I would put the stuff on, put the compound on. And that one, yeah, next picture. So there I am still, this time putting it on the peen. I do the whole thing at once. I don't bring one end up and then the other end up. I bring the whole thing up to temperature. I put the compound on it. I make sure it saturates. It'll dry up and become crusty. And then I will put it back in the forge and come back to temperature. So go ahead, next picture. Further ado. And all right, next. It's starting to dry up on the crustiness. So next. There is what it looks like once it's all pretty well crusty and the material has had a chance to gas off, and for the gases to go into solution a little bit on the edge of the iron or steel. So next picture. more pictures of that. This is a better picture of the end. Next. And so I brought the thing up to temperature. I put the mixture on, put the stuff back in, let that crust over. I put the material back in the forge, and then I bring it back up to that cherry red temperature again. So that bright orange. From there, I will take it and quench the whole thing. Rapid agitation in water is what I'll quench it in, because it is mild steel underneath. We want to cool it down as fast as we can. I suppose a brine might work, but it might make it too brittle. So next picture. So again, there's another picture of it before being hardened. Next. All right, after I quenched it and agitated it and stuff, I like to brush the remnants of the material off. So in this case, I'm just wire brushing it. It's wet, wire brush it off real quick, and then I'll take a look at it. So next picture. All right, more brushing. Next, there's me agitating the material in. So next picture, or agitating when I quenched it. So here, there's not the greatest picture, but a good picture of about where it was before I put the solution on or before I hardened it. So next, there it is, hardened, cooled down. I haven't brushed off the remnants of the material yet. And next. So on the control sample, it's coming up to heat. Next. There's the picture of the hammer. I'm trying to point at it, but you can see the dings in the 4140, the tool steel hammer face that had been hardened and tempered. And you can see the where I cracked off a little bit of the edge of the, of the control sample. And so I took that, I put it on the anvil. I'd suggest if anybody wants to test things like that, they put a piece of mild steel or something down on your anvil so you don't put dings in your anvil. When I do a control, usually on this sort of material or this sort of thing, when I'm case hardening something smaller, and I would, if it's a 1/4 inch or something smaller, I would put it in the vise and I'd see if I can break it and watch for the shattering, or you can do the test with a grinder and watch the sparks. But it's only a case hardening, so it doesn't through harden. But next picture. Okay, back to doing the control sample. I didn't do very much on cleaning up the control sample. You can see the end on the what would be the peen end where I cut it off. And next. And there we go, next. Got a lot of pictures of the same stuff. There it is with the material on it, all nice and crusted up. That isn't the best looking, but it looks good because of it's crusted right. So next picture. All right, more of the in-depth how it'll look when you're putting the stuff on. I tend to do it over the container so that way I don't lose material. Some of the time it will solidify though, so I try not to just dunk the thing in the container, besides the fact that it's a plastic container, so I don't end up with little glass beads of material in the container that I then have to try to crush back up. So next picture. Again, the that's a good indicator, the lower end of the color. So that there it's turning more of a red, or at least to me, it's more of a red than it is an orange. And next, there's the one of them. I think that would have been the control sample because I don't see a hole poked into it. Oh yeah, we're on the control sample side. And there it is, agitated. And next. So there again is another picture of continuing to hammer on the end of that. So you can see where the mild steel should have just folded over, and instead it shattered on the edge and it dug into the hammer that I needed to reface. This is an old hammer that I, it's got to be at least 8 years old that I made it.
I think I got an idea about what's happening. My question is, with a mild steel,
Right.
the compound you use is borax as a flux and sugar as a carbon source, right?
That's one of the things I've used at home to experiment with.
Yeah.
That one I did not have quite as much accuracy or quite as consistent results as when I did use the commercial made compounds. But every once in a while, it's a case of I need a hardened tool. This is what I have. I don't have to go run out and buy. I can just take a couple, mix up some stuff, charcoal, sugar, flour, whatever, as a carrier for the carbon, and then some sort of flux to coat it to help.
But the idea is to get diffusion of carbon into the mild steel, right?
Correct. Yes.
Yeah. Okay. Then I got it. Thank you. Thank you very much.
Yeah, you're welcome.
It's a sacrificial hammer.
It is a sacrificial hammer. I once upon a time I made some of my hand tools out of H13 and S7, and where most of them are out of like 4140. So the
H13 is air hardening, right?
Yeah. Most of them are the oil and water quenched medium carbon tool steels, but the H13 is air hardening, and so is the S7. And I figured out really quick that I need to use sacrificial hammers when I use these tools because they're harder than my hammers. And so when I have a hammer that I do not like, when I make hammers, I'll put them out so that either myself or students can use it on the tools. Though I make sure all student tools are all medium carbon. The struck ends are not hardened, so then the hammers hitting them are all harder than the struck ends of the tools. But every once in a while, I've noticed students take my hammer or my tools and play mix and match, and it's like, ooh, no, don't use that one, not with that hammer. I have a small pile of hammers that I'm not satisfied with. What I usually do is, if I'm not satisfied with the hammer, I'll turn it into a top tool, some form of top tool, and just I'll look at it. Usually one end I'll be fine, and you can use this, but you're totally unhappy with the other end, and so then I'll turn it into some form of top tool, a struck tool. So I've got to wait for me to get the hammer handled before I turn it into ones for people to use on tools. So, yeah.
Thank you for your answer.
You're welcome.
So, just a question on like the compound. Like you put it on like a red heat, yeah? Like
my perception of orange, and the reason this stuff is called cherry red is because in the 1800s or so, cherries weren't red.
They were orange.
They were orangish, yeah. And so it's a perception of the orange color at that temperature. So effectively, it's at a temperature where the carbon would go into solution if you were using mild steel, or the iron would be at a temperature where the carbon could go into solution on the outside on the casing.
All right. Yeah. From the compound, does it harden? Like, does it borax? It forms into this like glass mass. Is this more like glass or like body? Like what? Like does it
It,
harden in that sense?
it can, and that's why I try not to dunk the material or the metal into the container, because then I can every once in a while end up with the little glass beads that don't want to go anywhere. But for the most part, it stays pretty soft. I can put my fingers into it and rub them around, and it'll just flake away, and then have dirty fingers. Oh, one thing I did mean to say when I was doing this, don't just sit there and sniff and breathe the materials, especially if you have an older case hardening compound like casonite, because it contained arsenic and stuff like that. So it's not a good thing to breathe. So I try to do it where I got a good airflow, but most blacksmithing stuff is you're doing it where you got a good airflow anyway. Yeah. So Paul has, when I'm hardening and looking for temperature colors, the temperature colors, well, when I'm hardening by eye, and I'm really close to that same color, my perception of the same color, though when I'm hardening like a tool steel or a knife steel or something, when I'm doing that by eye, I'm a little bit cooler temperature than where this is for the case hardening compound. I'm more of a red. Usually the metals I use, it's usually about 100 degrees past the non-magnetic point. Or if you're doing it by eye, you could also, if you're not using the magnet, you could also use a table salt. It melts at about 50 degrees off from your typical hardening temperature for like the tool steels there. I'm not sure if I'm answering that question correctly.
That's okay. It's okay. I understand it now.
Okay.
Thank you. Thank you.
But just for the official protocol, I guess the question answered was, how does this method compare to hardening using seeing the temperature colors?
Most of the time when I harden for when I'm hardening axes and hammers and stuff for sale, I'll do my initial normalization out of the forge at a higher temperature, but then I use a heat treat oven so I can dial in the exact temperature I want for the next two normalization cycles, and also for the hardening when I bring it up, because when I'm doing the stuff for sale, and most of the time it's for sale, or I'm doing it showing a student how to do it field expedient at the forge, because they don't have a tempering oven, so they learn how to do it by eye. But when I'm doing it for sale, I want to make sure everything is as good as I can, so I use the oven for that. And it's a little bit less bright than the case hardening compound than when I use that.
Do you have a makeshift recipe for something to try out?
Well, the makeshift stuff was I put what had happened when I experimented with the sugar was we had brewing sugar. I was the head blacksmith and bladesmith for an outdoor survival company, and in the outdoor survivalist stuff, some of the people did their own brewing and stuff, and so they made their own beers, and they had the brewing sugar, but some ants got into it. And so I looked at it and I'm like, well, nobody wants to use that for making their beer because all the ants, and all the extra protein, right? So I got it, and I'm like, it's a way for me to put the carbon, and so I tried it, and I'm not sure my proportions, though I can. Lee Sauter has a video out. Daryl Markowitz, Lee Sauter, a few other people on.
I know Lee. Yeah.
Okay. He has a video out where they used a flour charcoal type mix. I'm not too sure on the proportions, the main thing when I used flour and charcoal and stuff, I did I cased the whole thing in clay, and then I let it soak in the forge, and so I'd end up with blister steel when I was done with it, and then you'd layer the blister steel and then make whatever you're going from there. But I did really thin sheets. Yeah, like that's an exact measurement there, thin. Yeah, but so I don't have a exact formula. I just put enough to I put enough borax in there that the ants left the sugar alone after that and they died. Yeah.
That's a good measurement for me.
Yeah.
I've got lots of ants.
I eyeballed it. And what I did when I eyeballed it and stuff was I then took some scrap that was a 1/4 inch thick material that, I could put in the vise. You could hammer it and bend it over normal, right? So there's your control sample. Then take another piece, put the stuff, put this case harden it using what you're making up, and see if it works. Put it in the vise, and if it breaks, well, if it broke, you harden it. So you got yourself in the ballpark. From there, you can start playing around. So maybe it only goes this far and then it breaks, as opposed to hitting it when it's up here.
Mm-hmm.
Though if you do use sugar, do it over a container because it drips and it gets sticky. And then if you're doing it over a cement floor or whatever, you're going screech, screech, screech every time you step and stick in the stickiness. Yeah. I figured that out when I was doing a public demo because I wanted to show that little formulation out. And then I was later stepping in the stickiness. But it smells like burnt marshmallows, if you like the campfire cooking marshmallow smell.